Good afternoon, and good evening, and good morning. Okay, good afternoon, and welcome everyone to session number 4. This is the security session, and we have a great lineup of panelists and speakers today. Akash Malik and Asif are facilitating the session from TSDSI, and Mr. Narendra Nath and I, Sharad Arora, are the session leaders with, as I said, a glittering panel of speakers and panelists. What I would just quickly check is to see if all of us are able to turn on our cameras and say hello over a microphone, just so that we know everyone is connected. So one by one, let's start. Akash, you are okay? Okay. Mr. Professor Saran, you are.
Hello.
Hello. Good evening and welcome. Mr. Narendrath, would you be able to check your camera and microphone? Okay, maybe some problem there. Mr. Sushil Kumar, sir,
Yeah,
are you?
good evening to all.
Yes, you're loud and clear. Thank you, sir. Thank you for joining today. Mr. Gopinath from Malaysia, MTSFB, are you able to hear us?
Yes. Good day, everyone.
Good evening. Mr. Sunil Gupta.
Yeah, good afternoon, everyone.
Mr. Vishnu Ram, your camera and your microphone for a minute. Excellent.
Yeah, good afternoon. Thank you.
And then have I missed out someone? I guess that is how it is. Mr. Singh, Mr. PK Singh from DOT DDG Security. Yes, sir, we are able to see you.
Yeah.
Are you able to
Hello.
hear us?
Good evening to all.
Good evening.
Thank you.
Okay, so what we should do quickly now is on behalf of Mr. Narendrath and the session, I'd like to invite all of us to this session on security. I'll make a very quick introduction to Mr. Narendrath, and for those of you who are associated with telecoms, he needs no introduction whatsoever. But for the general other larger crowd, it is Mr. Narendrath is an ITS officer. He is currently the Joint Secretary in National Security Council Secretariat with responsibilities for coordination in matters of cybersecurity. It's a very important office that is looking after these entities of India in government, public, and private sectors. He has a rich experience of 30 years in which he has looked after security of communications, network planning, installation, operation, and maintenance of fixed line, mobile, and data networks. Aside from telecom services, marketing, and business development and training. We would have had some context setting from him, but I'm just going to check if his connection is still going to allow him to make his audio possible. Mr. Narendrath, do you want to just check once? Okay, I guess there is some problem still with the audio. So what I suggest we do is that we go straight into the session. Please, can you bring up the slide that describes the layout of the session today so that I can very briefly introduce that to the audience? Thank you very much, Akash. Okay, and we will straight away move into the presentation by Mr. Sushil Kumar. Please, can you bring up his bio, Akash? Thank you very much. So again, Mr. Sushil Kumar needs no introduction to this community in India, at least. He is the most visible voice and counsel in the matters of IoT, smart cities. He has held the portfolio of DDG IoT in DOT for a very long time, and under his supervision, DOT has produced several technical reports, has released policies, and developed the ecosystem in IoT very much in the time when he has been in this role. He chairs many different national committees, more clearly the National Working Group 2020, which is coordinating ITU SG20 activities on IoT and smart cities. He is also leading the BIS LITD 27, which is a very important coordination between telecoms and the Bureau of Indian Standards. He's been a head of Indian delegations to various meetings in international organizations. He chairs the TEC Consultative Committee for adoption of 1M2M specifications, and has already seen the release to become a national standard under his supervision. I'm going to invite Mr. Sushil Kumar to please deliver his keynote now, which will serve as a great starting point for the session today evening. He will spend about 15 minutes trying to highlight the important points from the point of view of standardization and from the point of view of how that affects the Indian ecosystem and how that affects the global coordination and harmonization of standards. Welcome, Mr. Sushil Kumar, for your presentation. Would you like to share your own screen, sir, or would you like Akash to bring up your presentation?
Yeah, I'm sharing the screen.
Welcome, sir.
You are able to get my screen?
Yes.
Yeah. Thank you very much. And I am really thankful to Saratji and TSDSI for giving me an opportunity to present the TEC and the government view on the security as well as the IoT domain, mainly the IoT domain. And really, it's a wonderful event. And TSDSI arranged this event every year. So thank you again, and welcome to all my fellow speakers, the panelists, and the participants. So I am from Telecommunication Engineering Center, and TEC, that is the National Standardization Body for Telecom and related ICT sector. It is also the National Inquiry Point for WTO TBT, that is Technical Barrier to Trade for Telecom sector, and BIS is for non-telecom items. It has been mandated to coordinate with ITUT and having national working groups in line with ITUT study groups. It is the designated authority to implement mandatory testing and certification of telecom equipment. This is the flagship project going on under TEC, and designated authority to accredit the CAPS, that is the conformity assessment bodies. This, if we see the broad key technologies for the development of IoT, that is the top priority goes to the platform, then the intelligence, analytics, security, low power wireless networks, and the high speed and reliable internet at fixed and mobile devices. And the most important, that is the technology adoption roadmap for short term, mid term, and the long term durations. So these are some of the broad keys technologies for the development of IoT domain. And if we see the challenges, I've taken this slide from the ITU document, and it shows we need the robust connectivity, that is the latency, availability, coverage, and cost, which are the main factor. And second one is the standardization. Third, the interoperability and open interfaces, enabling platform to talk with each other. Fourth, the privacy and security. And fifth one is the domain knowledge. That is very, very important. And security, as this webinar is related to the security, end-to-end security of the IoT domain, that is from the device to the application. That is very, very important. As the hacking of the devices network being used in daily life will harm the companies, organizations, nations, and more important, people. If there is no security, then IoT will cease to exist, and it will not exist.
May I? Sir, I'm sorry. Yeah. May I just check if you can put this in a presentation mode, because that may be less visible otherwise.
Yeah.
Thank you.
Privacy of the data of the individual, that is very important, especially in the healthcare domain. Hacking of the smart devices, smart infrastructure, that may result in collapse of the services, creating panic, and may also result in chaos. And this is a study. A global Internet of Things security market size is expected to grow from $8.2 billion in 2018 to $35.2 billion by 2023. So this is a big projection. Then TEC initiatives in M2M IoT domain, as already mentioned by Sarajji, we released around 15 technical reports with the help of the industries, and we included all stakeholders from the country as well as from the foreign nations. ITUT recommendations, that is why supplement 53 on IoT use cases and 56 on smart city use cases, they are having significant contributions from TEC, IoT Experience Center. It is having around 17 use cases. 1M2M release 2 specifications. It has been adopted as a national standard, and TS 0003, that is on security solutions. So platform 1M2M standard is the key for the development of the interoperable platforms. And TS 0003, that is the on security solutions. It provides the necessary security and will be able to detect the rogue devices in the network. 3GPP release 10 to 14, it has been adopted as a national standards. Essential requirements for various products and the telecom equipment have been prepared, and these are related with the IoT domain. Work in it that is in progress, that is emerging communication technology and use cases in M2M IoT domain. Here we have covered 5G, Wi-Fi 6, Wi-Fi 6E, Bluetooth Mesh, Wi-Fi Hello, and the use cases that is cellular V2X and the industry 4.0. Then we are working on IoT ICT standards for smart cities, the security by design principles for M2M device manufacturers, and National Trust Center. The work is in progress, and in the sideline we released a document, that is code of practice for securing consumer IoT, and that is based on ETSI EN 303645 and the global best practices that we will see in the coming slides. Evaluation of public events on 1M2M release 3, 3GPP release 15, and 5G standard that is developed by TSBSI, that is in progress. And we hope in this financial year some conclusion will come on this. Then this is basically one of the slide. It shows the smart city platform as the brain of the city. If the brain is smart, then the smart city will remain smart for a long time, not only for the present generation, even for the future generation. And it also shows the security and the privacy at the platform is also very much important, and which we have shown that TS 0003 in the 1M2M that will take care. Yeah, these are some of the standards.
Yeah, I think.
This ITUT Study Group 20, ISO, IEC, JTC1, SC41, 1M2M, and IEEE. These organizations are working. A number of other organizations will also be working on IoT domain. But what is important, the interoperability between the various standards, that is very, very important. Suppose tomorrow some standard comes from IEEE, then it should have the interoperability with the 1M2M standard.
I'm audible now.
Then 1M2M, why it is important, that it breaks the service silos by creating the service layer, and 1M2M was originally created for having the service layer standards. Then I can skip these slides because we have already spoken these 15 technical reports which were released, and then some of the outcomes which came from these technical reports, that is 13-digit numbering scheme, then the embedded SIM with over the air subscription provisioning, and it is very important, and it has been mandated by Ministry of Road Transport and Highways in its vehicle tracking standards, and further included by BIS. Then the IPv6 for the gateway and devices to be connected directly to PST and PLMN. Then testing and certification. It is also related with the security. This it is having EMC, then the technical protocol, IP, SAR, and the security standards. The devices are to be tested on that. Then the common service layer that we have already discussed, then the spectrum and the licensing, etc. Large number of recommendations came from this. This is from the related with the testing and certification, which we have discussed just now. And it is being implemented in the phased manner. Now phase 3 is in progress, and then the phase 4 will come, will include large number of devices. Then the security of the IoT domain, the 2 documents related with the security have been released in TEC. One was released in 2019, that is the M2M IoT security recommendations, and then this document, Code of Practice for Securing Consumer IoT, has been released recently. 3 provisions in this of this document, that is no universal default password, implement a means to manage reports of vulnerabilities, and keep software updated. These 3 items will be mandated in future, so we can think of it and work on it, how to manage mandate it. Even if the certified devices are deployed, there are chances of some of the devices may become vulnerable. Such type of devices are required to be detected by the concerned IoT platform. And to address the issue of security vulnerability, concept of National Trust Center that has arisen, and it was mentioned by the TRI in its recommendation, which were released in 2017 and further adopted by DOT and given to TEC to carry forward the work. The work is in advanced stage, and we hope in this financial year the work will be over. This slide we have taken from the IoT SF document. It mentions that only very few IoT device manufacturers, they manage the vulnerability, and this survey was taken from the companies of North America, Asia, and the Europe. So only 13.3% in 2019 they are having the vulnerability disclosure policy. So this is very, very important that we should work on this to mandate some of the provisions. Then National Trust Center, this for the it is a sort of, it will be a sort of repository to have the M2M device manufacturer, the application service provider, and the M2M service providers to have this repository, and it will be connected with the various sub-registries of different verticals and the IoT platforms. Then suppose some of the devices is found to be rogue devices, then it should be communicated to the National Trust Center, and which will be having the details of the manufacturers. Either the vulnerability should be managed by the manufacturers or by the researchers. So such type of items are required to be created in the policies. Then different type of interfaces will be required, and for the registration of various entities in the NTC, it is required to bring it in some policy, and I think M2M device M2M device register M2M SP registration policy, which has already been circulated, is expected to come in near future, and that will have these provisions. So DOT released roadmap in 2015. Then NDCP is also covering all these items, TRI recommendations, then draft IT policy, and this M2M service provider registration policy, which will come in near future. Then these are some of the issues: technical interoperability and standards, which are very important. Security, in general, it is seen that security is generally the last option for the device manufacturers. It is a live example with all of us that the broadband modems are configured with user ID and password as admin even today, and it has been found in the various documents across the globe also. So it is not the situation in India; it is the situation even in the developed countries. So a licensing framework to evolve to meet the challenges of IoT licensing, data privacy, data localization, and then availability of network addresses, cross-border traffic, spectrum requirement, the connectivity to ensure quality of service, governance, and as IoT is for the vertical industries, telecom regulator and industry vertical regulator are expected to coordinate while framing the regulatory requirements. So these open standards and interoperability, they are the key to the resilience, sustainable and scalable growth of the IoT verticals and the smart infrastructure. Thank you very much for listening. Thank you.
Thank you, Mr. Sushil Kumar. I can now hand back, if possible, the control to Mr. Naren Nath. I hope you can hear us, sir.
Yeah, I'm able to hear you.
Welcome back. There's always this thing about the last minute issues with communication and setups. Maybe Akash, if you can take us back now a little bit so that Mr. Naren Nath can still do a quick context set. Although Mr. Sushil Kumar was kind enough to add the standards piece, but let's see. It's good if Mr. Naren Nath can.
I'll take my 5 minutes.
Of course, sir. Back to you, sir.
Yeah. Okay. So thank you very much, and welcome to all the speakers, keynote speakers, Mr. Shirad Arora and Mr. P.K. Singh, Mr. Sushil Kumar onto this, and the panel that we have got today, where we have Mr. Gopinath and Mr. Professor Huzur Saran. Mr. Sunil Gupta from the Keynote Labs, and Sushil Kumar is again coming on the panel again, and Vishnu Ram from the TSDSI. So welcome to this panel and all the keynote speakers to this tech deep dive on this session where we are talking in terms of securing 5G, IoT, AI, and beyond. Let's go to the next slide, please. Yeah. So one of the things that I just wanted to bring forward here is some of the things that are developments that have happened and that issues that are seeking attention, actually. So one is regarding the software defined and disaggregated networks. So we find that most of the networks are now software defined, and you're also talking in terms of disaggregated networks. So you talk in terms of 5G, the architecture that's come about, or the IoT deployments that are happening, and the open RAN that we're talking about. So in these cases, there are security issues that are popping up, and one of the issues that has become some sort of a pet subject where I talk in terms wherever you have bilaterals also with other countries. This is one thing that we have flagged is this secure by design. Secure by design is something that it's a topic that we talk about, and we want all the people who are on developing software to take security as one of the aspects right at the time of development of software. And we assume, that in the telecom networks, especially when we have big operators that are coming in, they have robust practices in place, and they would be having secure by design and coming up with secure software design and secure products from the design perspective. But when we have this software defined networks, disaggregated and open architecture that's coming about, when you have smaller players coming in, how do you enforce secure by design across all of them? And then you have a secure product coming in is one challenge that from our office we are looking at, and we find that this is something that that's been exercised in the minds of other countries also. So that is one. The other is this user devices with large scale deployment of smart devices that's happening, and different applications that are riding on that. And this is one area where we find that how do we protect our citizens from and see that they have access to secure devices and secure applications. In this area, I'm glad to see that TSDSI has worked, and they have a group on MDPP, Mobile Device Privacy Protection group, that has come up with a technical report on this. And I also know that the NCCS, the National Center for Communication Security, has come up with ITSA, the Indian Telecommunication Security Assurance Requirements for mobile devices. But still, there's work to be done on applications and how to, certify applications so that people only put secure applications onto the devices. Then we also have this new technology that are emerging, AI and quantum, that's happening. The impact of those on the security, and also the how these technologies can be used to enhance security. This is another aspect that is there. And finally, the aspect of supply chain security. And you would be observing across the world, there's talk about supply chain security, and we have had incidents like where the supply chain has been contaminated, and you find that through the supply chain, large scale, malware has gone into systems. So one part of the supply chain security is, of course, that you have service providers who get infected, and those through that service providers, their clients also get infected. That is one part of the supply chain security. The other part of the supply chain security is actually the equipment that comes in, and how do you secure that equipment, and that is one part. What are the mechanisms, the processes, procedures to see that the supply chain is secure? So these are some of the issues that were there. And when we're talking in terms of tech deep dive, we were looking at let us try to address these issues that are exercising our mind now. The user device and application is something that we talked about last time, and that to a large extent there's an activity that's going on. But with other aspects, there is some deep dive that is required to be done. And we want this particular forum and this particular session to work on that. And that's how we put together this panel, put together this keynote speakers to address those issues. So with these words, I would like to hand over back to Mr. Sharad Arora to take this session forward. Thank you.
Thank you very much, Mr. Narendranath. I think what you have described here is so interesting, setting the context with the issues with software-defined disaggregated networks, securing user devices and apps, the issues with supply chain security, and the new technologies, AI and quantum. We are now going to request Mr. P.K. Singh. Please bring up a small bio. Thank you very much. Can you put this in presentation mode, please? Please, the bio. Thank you. So Mr. P.K. Singh has an equally visible face in all of what has happened in the last 10 years, first from TEC, then with DOT. He is currently serving as the DDG for Security Assurance in DOT headquarters. And he has earlier been in teams that have helped the planning, tender document preparation, evaluation, and testing and rollout of networks for a very, very long period of time. He's looked at packet networks, VoIP networks, managed lease line networks. So in that sense, with broadband access, etc., has a very good background and experience to now handle this very important charge. He's also been a member of the TRAI committee that looked into the recommendations of how to increase internet access and penetration, which has led to the deployment of Internet Exchange Points, NIXI. I would like to welcome Mr. Singh, if he can take 15 minutes to please give us a policy perspective. We have seen Sushilji do the standards perspective. Mr. Singh, please, would you like to make your own presentation, or would you like Akash to present?
Thank you, Sharad. I think let me try to share my screen.
Sure, sir. Your screen is visible now, sir.
Yeah, just I'll put it in the presentation mode.
Thank you, sir.
And then we can start. Yeah, thank you. A very good evening to all. In this brief presentation, we would be looking specifically at the role of policy in securing the national infrastructure. When I say role of policy, the word is very broad. So I would be emphasizing on the role of security policy in securing the national infrastructure. When it comes to national infrastructure, it is basically the national communication infrastructure or the national telecommunication infrastructure. Although what I would be presenting is fairly generic and can apply to any infrastructure sector. So here we are, and thank you to TSDSI for giving us an opportunity to share our views on a very important topic. Basically, first of all, what is a security policy? And before we take up what is a security policy, I would like to give a brief introduction on why the topic has been selected. Over the past few years, as use of information communication technology has proliferated, there has been a rapidly growing awareness on the part of all ICT users of the need to ensure effective protection against cyber threats that continue to increase and diversify with alarming rapidity. The widespread use of various devices over the networks, and in particular the ability to access and control so many aspects of daily life via communications, has meant that it is now essential to build solid security protection into industrial, commercial, and consumer products and services being offered through the telecom service providers, networks, and through the markets. And also, we have to ensure that the sufficient attention is paid to security throughout the entire life cycle of the product as a product or service. And that is the background why the role of a security policy emerges. So, what exactly is a security policy? There are many standard-based definitions. When we take a look at the various international standards, how they define the security policy, some of the definitions are from the ITU. The first definition, which says the set of rules laid down by the security authority governing the use and provisions of security services and facilities. This is one definition.
So may
Another
I?
definition. Yeah, please.
Sorry to interrupt you. So your slide is right now showing role of policy in securing the national infrastructure. Could you just check that when you went to the presentation mode, the presentation was still visible? We are still only seeing the first slide, role of policy in securing the national infrastructure.
Now is the second slide visible?
Maybe you can stop sharing and share one more time. Sorry for that interruption, sir.
Yeah, it's not visible here.
Yeah, now it is. Now what we see.
No, we revert to the first slide again.
Now is it visible?
Yeah,
Go
only
to
the first slide.
It is still on first slide.
Yeah, but you had been able to transition to slide number 3 in between.
That was okay.
Yeah, your cursor is visible. Now you are on slide number 2.
Now is the third slide visible?
Yeah, second now.
Second slide.
So basically, I'm not able to change the slides. I would request Akash to help me out in this regard.
Akash, can you please, sir, if you stop sharing, we will
Yes.
check if Akash can put it up.
Yeah, I have stopped sharing.
Thank you, sir. Akash, can you? Thank you very much.
Yeah, thank you. So coming to what is a security policy, after the brief introduction and brief hiatus, we resume. There are certain standard-based definitions available. The first definition, which I have picked from ITU recommendation, X.509, the set of rules laid down by the security authority governing the use and provisions of security services and facilities. There is another definition, a set of criteria for the provision of security services. A complete security policy will necessarily address many concerns which are outside of the scope of OSI.
Akash, I guess you stopped your presentation.
Yes, request Akash to please project the presentation. Yeah, thank you. What is security policy? Yes, let us be on the second slide. Now, there are many standard-based definitions available. A very wide encompassing definition of a security policy is that it is a written document in an organization outlining how to protect the organization from threats, including computer security threats, and how to handle situations when they do occur. A security policy must identify all of a company's assets as well as all the potential threats to those assets, and the company employees need to be kept updated on the company's security policies, and the policies themselves should be updated regularly as well. The policy contains the security requirements which are both generic and context specific. In addition, some requirements are well established while others continue to evolve with new applications and the evolving threat environment. So security policy is not a static document, it is a live document. It is a live and kicking and getting continuously updated document. The security policy makes use of tools, personnel, security concepts, security safeguards, guidelines, risk identification and management approaches, actions, training, best practices, assurances, and technologies that can be used to protect the cyber environment, the organization, and the user assets. And the security policy translates the security goals which have been defined by the organization into the organizational processes, high level and detailed technical security requirements. And the technical security policy drives the security lifecycle and the implementation of security across the systems and solutions lifecycle. And one very important aspect of the security policy is that it also gives due consideration to the government requirements and incorporates that in the security policy. Yeah, can we move on to the next slide, please? Basically, when we talk of a security policy, there is one word which is very important, that is secure. So what exactly is meant by secure in the security policy or anywhere whenever we come across the word secure? There are many standards which comprise the definitions of the basic security services uh, which are provided. So just conforming to those security services is sufficient to designate a particular network, a particular service, a particular action, a particular process as secure? No. The answer is that when we have to consider a particular product, a particular service, a particular network, a particular action, a particular process, etc., to be secure, there is a lot of requirements which needs to be fulfilled. And the ITU, what it has done is it has basically broken down all these things into three major concepts, which are defined as security layers, the security planes, and the dimensions. And if you are able to fulfill the requirements of secure in security layers, in security planes, and in dimensions for an end-to-end network, then only it can be considered as secure. So what exactly is meant by security layer? Any network, whenever it is deployed, it will comprise of three different, functionally different layers. We can think of a network to comprise of an infrastructure layer, a service layer, and an application layer. So all the three layers need to have the processes, practices, tools, testers, etc., to make it secure. And when it is considered as secure, when the security plane represented by certain type of network activity protected by security dimensions is secure. Basically, the network can be considered to be comprising of three different planes: the management plane, the control plane, and user plane, across which or through which a lot of information is flowing. If they are secure, and when they are secure, there is a requirement that all these layers and the planes, they need to fulfill the security dimensions. And what are these security dimensions? Security dimensions are set of security measures designed to address a particular aspect of network security. And the basic security services like authentication, access control, data confidentiality, data integrity, non-repudiation, communication security, availability, and privacy, along with more general services such as trusted functionality, event detection, security audit, and security recovery, needs to be fulfilled by the infrastructure layers, the application layers, the service layers across the security planes. If these things are happening, then we consider it to be secure. Can we move on to the next slide, please? Yeah. So basically, when we are devising our security policy, what are the objectives of devising the security policy? The security policy has to have provisions which will define how the access to network and services is to be granted, whether it is to be granted to all or whether it is granted to a set of users on the basis of the authorizations. Then it also contains provisions who are the authorized users. The security policy needs to define that the network has to support the confidentiality to the level prescribed. It also has to have entities which can be held accountable for their own actions, but only their own actions. Uh, the other objective of the security policy are in front of you, and we basically are not going to devote much time, but in order to can we move on to the next slide, please? Yeah. The objectives of the security policies are one of the very important objective of the security policy is to protect the asset, uh, and that asset is to be protected for customers, subscribers who need confidence in the network and the services offered, including availability of services, especially the emergency services. The assets are to be protected for public community, public authorities who demand security by directive and or legislation in order to ensure availability of services, privacy protection, and fair competition. This is where the government's requirement and government's considerations are to be taken care in the security policy. It is also required to protect for the network operators and service providers who need security to safeguard their operations and business interests and to meet their obligations to customers, their business partners, and the public. And what are these assets which needs to be protected? These assets may comprise of communication and computing services, information and data, including software and data relating to security services, the personnel, the equipment and facilities. And achieving these objectives require that close attention be paid to the security during the network planning and design, implementation and operations. The security policy is the document which lays down all these activities into a single document. Yeah. So can we move on to the next slide, please? Basically, when we are saying that security policy comprises of the rules, policies, etc., we need to understand that the security policy is not a static document, and it is not a document which starts and gets completed. It is basically a continuous being updated and a cyclical document wherein whatever is defined for the definition and planning part of the network phase is the inputs generated from the first phase are basically the results generated in the first phase are given to the inputs as for the second phase and for the next phase, and once it has been deployed and maintained and is operated, so whatever inputs the results get generated, they are basically fed back to update the definition and planning. So that is what is basically meant by the network security life cycle. Can we move on to the next slide, please? So coming to the importance of a security policy, uh, the organizations, they basically need to devise a comprehensive plan for addressing security in each particular context. And security is not one size fit all. Security should be viewed as an ongoing a process that covers protection of systems, data networks, applications, and resources. Also, security must be comprehensive across all layers of a system. A layered approach to security combined with strong policy management and enforcement provides a choice of security solutions that can be modular, flexible, and scalable. And one more thing which is very important, that the security policy has to be standard based. Why standard based? The standardization and the use of policy based on standard profiles facilitate interoperability and the reuse of solutions and products, meaning that security can be introduced faster, more consistently, and at a lower cost. Standardizing network security solutions benefit both suppliers and service providers through economy of scales in the product development and component interoperability. And in a complex multi-vendor environment, standard-based security solutions can ensure interoperability and operational efficiencies in realizing end-to-end security. The network operators depend upon the key security information to plan, design, implement, and maintain secure network to meet the organization's business and technical goals. The industry needs a uniform set of security guidelines that can be consistently applied to relevant phases of the system and network lifecycle to realize the benefits listed in the slide in front of all of you, which are a common approach leads to a shared understanding and interoperability in multi-supplier network, an identification of hierarchical assets and what is needed to protect them, a consistent way to look at threats, vulnerabilities for products regardless of technology. A systematic analysis assures efficient coverage of network security, a requirement of network forensics after breach/incident detection, the network and restoration and resilience in case of a disruption. It also ensures the deployment of a secure product after ensuring the supply chain security and testing and certification. It also prevents remote access to critical network elements, and at the same time, it also ensures the access for proper operations. So we basically have examples of what comprises the security policy or the policy. The security conditions in the license granted by DOT to the telecom service providers has a very good chapter on the security policy. The mandatory testing and certification of telecom equipment scheme of Department of Telecom is a part of security policy. The National Security Directive on Telecom sector propounded by National Security Council Secretariat is part of the security policy. The Section 5 of Indian Telegraph Act 1885, the Section 69 of IT Act 2000, etc., all are part of the policies on security for telecom sector, and it is these set of policy requirements which, when complied with in letter and spirit, will ultimately lead to deployment of a secure telecom network and services. Thank you. That's all from my side.
Thank you, Mr. Singh. So, Mr. Narendra,
over to you, Mr. Sharad, for taking the session forward. Thank you.
Thank you. If you permit, Mr. Narendra, I will go through my presentation now. Just want to check that my screen is visible.
Your slide has come, yes. Your screen is visible. And then we should have your bio data.
Maybe we can, we are 5 minutes behind. So
yes.
Maybe I can skip that part with your permission. I will try to wrap up my presentation so that the very interesting panel can be handled. And I just want to say, if possible, for Mr. Singh to stay for the panel, because he said some things at the very end of his presentation. He cited some very important policy sections that might just be of interest to the audience, but I don't know if logistics will permit such a thing. But I would have found it very interesting to have some discussion on the last few points that he made. It was information even for me. But right now, with your permission, sir, I will try to take 10 to 15 minutes to set this context.
Yeah.
Thank you, sir. I'm trying to marry a lot of what has been said by Mr. Narendranath when he cited the new threats and the new technologies, and when Mr. P.K. Singh cited very importantly the security policy importance, and then Sushil ji had earlier cited the security issues with the industry. He said it's normally the last priority for manufacturers. And I think that is the case because mostly it is not so clear as to what has to be done. So I will try to provide a perspective that can help us with the panel. My agenda is to discuss the cybersecurity, part of which actually Mr. P.K. Singh already covered, dimensions, layers, and planes. Also to cover security frameworks for trusted ICT infrastructure, to make a very quick show of what is really the difference between 4G and 5G. I'm going to oversimplify it, but still for the audience to get some view of it. And then discuss why this talk of security for IoT and 5G, what is so new. Discuss what is the importance of service provider enabled trust for devices and apps. I think it is very clear to all of us that unless security becomes part and parcel of the service and comes at an affordable cost, logistics and processing resources, it will remain a barrier. And what can service provider enabled trust do to mitigate that concern? And of course, the whole certification and trust registrars, the role they can play for a global security framework. That's the industry perspective. Mr. Singh already described to us, so I don't need to stay very long, that we need to manage threats across the various layers, planes, and dimensions. And these have been very nicely captured at the level of standards, the ITU standards. They fully describe to an organization that is interested what are the things that a product, a service should consider. But then also security, trust, and trusted ICT infrastructures have relied upon time-proven triads such as confidentiality, integrity, and authentication, which when topped up with non-repudiation brings you a complete security and trust framework. But then in the new generation of devices and services, there are so many broken domains. It is not like in 1994 when you made a GSM call where your phone connected to a radio access network through a core network that all belong to one operator. Now, there are so many different domains, so many different packet domains, and so many different service providers who have to provide different levels of trust. So there is a need for a physical trust because the phone that was yours 20 years back are now devices that are widespread, dispersed. They don't belong to anyone, but they have the same secure element and the same power to connect. Then there is the cyber trust. And lastly, there is a social trust. We are all familiar with the manipulation of voting with social networks. So the dimensions of trust and the dimension of security are actually changing very rapidly. In terms of 4G and 5G, the big difference is, of course, the service-based architecture and the need for devices to find alternate paths to alternate applications. The telco network is now really just a bit pipe, and sometimes it's not even the bit pipe. Sometimes you are using the Wi-Fi network and you are using the EAP authentication. So everything becomes disaggregated. And in that disaggregated, federated method of providing services, we have to find secure and trustful transactions. That is the challenge. And what's with IoT security? Basically, the problem is that we are talking about billions of devices, and we are talking about these billions of devices trying to find their way to applications that no single person controls and no single person delivers. As a result, there is, from constrained devices that don't have so much security knowledge, that don't have so much security capability, an urge to reach their service providers through various types of networks. And then when we look at the 5G side of the story, the architectures that are coming in now are exposed to much larger threat vectors due to virtualization and distribution of network nodes, open radio access networks, multiple slices sharing the same network pipe. So there is a lot of new threat vectors, a lot of leakages from across management, signaling, and user planes. And we still have to find a method to control and manage the threats that we can see in this environment. And that is one of the big reasons why so much talk about 5G security and so much talk about IoT security. In one word, IoT security with 5G networks is not the sigma, but a multiplier of threat vectors that existed in the internet and the threat vectors that existed in the mobility world. So this is the context here. The device population will grow and exceed the mobile population. These intelligent devices will choose connectivity intelligently from a choice of various networks. They will find their path to the services through secure and open interfaces. And basically, what is very important is to acknowledge that an alternate authentication mechanism that serves end-to-end security is likely to be the most important next thing that happens, such that the transport and the service are equally protected and differently managed. One of these aspects was very clearly brought out in a security report published by Telecom Engineering Center, M2M Security Report, in which the importance of the root of trust inside devices and security classification of devices, followed by registration and certification of devices such that identity and authentication can be managed, and the use case classification and a differing level of compliance for critical use cases. These three matters have been discussed at great detail, and that can remain as the foundation for how to realize a trust model in which the existing capabilities of the roots of trust, existing capabilities of identity and authentication can be used to leverage end-to-end security. And that is where the service provider trust framework becomes important. How can we utilize the existing primitives of security, such as to enable end-to-end encryption for such devices and applications that are operating on top of the telco networks or on top of the communications network? And this is the concept that DOT proposed in a standard to ITU. ITU-T Y.3056 became a global standard in Feb of 2021, which basically brings a completely new definition called bootstrapping. So DOT, Department of Telecoms, has given the world a new definition of bootstrapping, which says how to use the existing trust primitives within a communication service provider for enhancing the security for device and application, and making it possible to be using those primitives in end-to-end trust implementations without having to find more costly and new ways to implement end-to-end security. Simultaneous to this is the discussion about how to then ensure that we can distinguish between the good and the rogue. How to make sure that the widespread use cases, devices, and apps can find some form of a registration in which certification followed by a word that was used in two presentations earlier, life cycle. Over the life cycle, how can we ensure that devices and their controllers, for example, applications, or for example, IoT platforms, know that those devices still do what they were expected to do and now are not compromised or have not turned rogue. The concept of National Trust Center was discussed in this particular regard. And in terms of how this whole thing comes together from an industry point of view, this open, diverse ecosystem of certified devices as per the DOT mandatory testing certification of telecom equipment, this very policy and regime can provide the various different industry verticals with a trusted source, with a trusted identification, and that when worked with 1M2M common service layer platforms, together with the ITU Y.3056 bootstrapping, can provide a very sustainable, globally harmonized method for developing certified service providers, apps, and device ecosystem. And this is one of the important industry perspectives that I bring here, that with what India has done by bringing in national standards from 1M2M, by the ITU Y.3056 standard for bootstrapping, is basically provide itself a possibility of bringing along another Aadhaar, not for human beings, but this time for devices and apps. And in quick summary, the 5G communication network architectures are being restructured. We all know that, and we need new principles for security by design. There are new actors and business models which bring in greater complexity in service delivery, access control, and authentication. Topped with that, the massive IoT device population and widely dispersed geographically a-personal nature of use cases, constraint device capabilities, these facets are working together to expose many different threat surfaces and threat vectors in IoT services. On top, technologies such as quantum are forcing out very well-established encryption algorithms and security technologies. As a result of which, 5G and IoT, they require a very fresh and important relook at the criteria for selection of trust models, frameworks, roots of trust, security by design principles, and end-to-end encryption capabilities, such as to still keep the entire ecosystem secure and intact. And this, when done properly, is going to be of tremendous value to users, manufacturers, registrars, governments, such that all of them work together in a manner that not just for one country, but for a global collaboration, devices and applications interwork and interoperate in a manner that is trustworthy and in a manner that follows standards and follows certification. That is my summary before we launch into the panel. Thank you very much. I will stop sharing this and hand it back to Mr. Narinnath.
Thank you, Mr. Arora. I think we have set the tone now for going along to the panel discussion. And so I would, so should we start off with the panel discussion now?
Sure, sir.
No? Okay.
Maybe we can make a quick introduction to the panelists, brief on their.
So we have the panel now of. So do we? I would like to have the the biodatas flashed as we go ahead. Okay. The first panelist is Mr. Gopinath Rao Sinaya from the MTSFB. He is the chairman of the Internet of Things and Smart Sustainable Cities Working Group under the Malaysian Technical Standards Forum. He is also the CTO and co-founder of Favorite SD and PhD, a startup focusing on IoT platform and solutions. He holds a doctor's, master's, and bachelor's degree from the University Science Malaysia in computer science. He has architected many IoT solutions in current and previous organizations. He has many years of experience in various IT industries with focus on research and development, an expert in IPv6 and Internet of Things, and a leader in standardization forums locally and internationally. So he's the first speaker. So welcome, Mr. Gopinath.
Thank you,
Sir,
Sarendra.
we also want to thank MTSFB, sir.
Yeah.
MTSFB and PSDSI are starting to work very closely and collaboratively, and I think that's a fantastic development. Thank you, MTSFB.
Yeah. This second speaker on the panel is Professor Husnu Saran, whom I have met earlier also in many forums, as a professor in the Department of Computer Science and Engineering at IIT Delhi. His research is focused on computer networks and algorithms. His group has been working on a rural content distribution framework for building disruption-tolerant applications, and in the area of peer-to-peer audio-video collaboration frameworks for online education, supported in part under the National Mission of Education through ICT. He did his PhD in computer science from the University of California, Berkeley in 1989. During the 2002, he was a visiting professor at the Information Systems Lab, Stanford, where he worked on the media access control layer of an exploratory 4G wireless systems. He has been investigating wireless access and mesh technologies to enable ICT for rural masses. And I know he's been actively involved with AI for 5G, the webinar series that ITU is doing. Yeah, welcome, Professor Saran, onto the panel.
Thank you.
The next speaker on the panel is Mr. Sunil Gupta from the Keynote Labs, who's a co-founder and CEO of Keynote Labs, which is offering ready-to-deploy quantum secure products and solutions. He comes with product engineering background with a passion to identify cutting-edge technologies and build solutions to solve interesting and important industry problems. His expertise lies in achieving product and market fit for the market success. He's worked in CDOT, Hughes Software Systems, Symphony Teleca, Infosys, and Edgeverve in different leadership roles. He did his BTech in computer science from NIT Trichy. And I'll also share that there's a project that we are funding, working together with Unilabs.
Yep, pleasure to be on the panel. Thank you, sir.
Thank you. And then we have Mr. Vishnu Ram. He's an independent research consultant. He has hands-on experience in the field of telecom industry for more than 2 decades, developing and implementing standards, and holds many international granted patents. His current work items include coordinating standards initiatives, liaisons with SDOs, industry bodies, open source, and academia, mentoring student projects, and coordinating the ITU AI/ML in 5G challenge across the globe. He served as a guest editor of the JICTS Journal of ICT Standardization special issue on Zero Touch Network and Service Automation. Vishnu is an active member of Networking Group 13. And so welcome. He's now part of the TSDSI, and welcome abroad to the panel.
Thank you very much. Thank you. Yeah.
Thank you. And okay, we have Sushil Kumar also on the panel, and who has been introduced. He's from TEC, a DDG in TEC, looks after IoT, and he's been introduced earlier by Mr. Sharad Arora. So welcome, Sushil, also onto the panel.
And welcome, Mr. Singh. I think your presence on the panel is going to add a lot of clarity with questions and discussions. Mr. Narendra, thank you very much for setting this up, making the invitations and introductions. So should we now bring up the conversation that you have been so eager to, Mr. Narendra? You have been very eager to address some questions to this very, very well-appointed panel. And I have the role of asking the questions, and then Mr. Narendranath has the role of interrogating the panelists. So we made it easy for each other. All right. So I will say good evening to the panel and good evening to everyone. Good morning for those who are in different parts of the world. Be aware that we are very keen to answer your questions. Please raise your hands or put questions on the panel. We will try to do our job efficiently, so we have 10 minutes at the end to pick up audience questions. But the first matter is about security by design. And the question that is on the table is that in this new world, different from what I knew when I started my telecoms journey in 1995, which was one network, maybe one supplier, one monolithic MSC location, and one physical location, one militarized zone, one systems and operations management. That's what we knew 30 years back. And today, we are starting to make the journey in which everything is disaggregated. Network nodes are disaggregated. Virtualization means you don't have the same sort of robustness in the physical orchestration of your hardware. Distributed nature means that you've lost the proximity, you've lost your vicinity in that sense. And openness means that systems will talk to each other, made by different smaller companies and talking over interfaces that are new. In this world and in this type of an orchestration, Mr. Nath has a question to the panel which says, what are the practices and what are the technologies that are required to still maintain the principle of security by design? I'm going to distribute this question to Professor Saran, after that to Mr. Gupta, and then let Mr. Naren Nath guide the conversation for the next 10 minutes on this very important subject. Over to you, Professor Saran.
Thanks, Sharad. So, yes, definitely, if you look at the history of telecom and look at 1G, 2G, 3G, so as we moved from 3G to 4G, slightly more of the IATF kind of internet-style interfaces started coming in. We see, and with 5G, we have moved to so many of the REST APIs between different components, disaggregation of components. Components can come from different vendors, multi-vendor. So we have opened things up. We've also started using many of the common protocols, whether it is JSON, whether it is REST APIs, whether it is OpenAuth 2. Many of the standardized internet protocols that are otherwise being used in the industry are now being used to build, and then of course containerized applications, the service-based architecture. All of this we normally saw in other applications, we are now seeing in the telecom domain. Now that, as has been pointed out, has benefits and risks. The benefits are you are doing well understood technologies. You see, earlier when a major vendor implemented all the protocols, the standards were developed by 3GPP or the corresponding GSM standardization before that, but they were implemented by one vendor in an integrated manner. It was tested in his lab. The whole system engineering was done by one vendor and everything was tested together. And also, since most of the internal interfaces were secret, often even if there were vulnerabilities, a third party did not have easy access to exploit those vulnerabilities because it did not have knowledge about those vulnerabilities. Now, with all these being open standards, what happens is every open standard, occasionally some vulnerability gets discovered, then a patch comes. But so this is one aspect that it is each of the different parts are very much more thoroughly analyzed, much better understood parts because they are being used all over the industry, not just in telecom. But there are also vulnerabilities that do come up from time to time in different parts. And the real challenge is that in the end, who's putting it all together? See, what is happening is now the telecom operator is buying these disparate software pieces and some hardware pieces from a multitude of vendors, and then he has to deploy them, right? And normally the telecom providers are not really have that kind of infrastructure where they can, at most they will do an interoperability test to put all the boxes together to say it offers functionality.
Absolutely.
But they will never do a full system engineering test, look at all the APIs, the fact that you have, and look at all the security vulnerabilities, the composition of all these different boxes put together, which is being done only in your implementation. Because the other implementation will have some other composition. So that composition is not getting tested, especially for security testing. And that is something I think we need to encourage the telecom vendors. If you're going to deploy something, you need to not only do the interoperability from functionality and scalability perspective, but you need to have a secure fuzzing lab which tests the whole infrastructure as a whole thing together, because you are the only person putting this combination together, right? There's the other problem here also related to this is that when you have all these open pieces, you keep getting upgrades. SSL TLS gets upgraded from 1.2 to 1.3 to 1.4. Every piece gets upgraded. So the pace of updation is faster because everything is softwareized. Pace of feature rollout and updation is faster. That's a positive, that you are able to roll out with the same hardware new features. But the flip side is with more rapid change in the code base. Yeah. Every time you do the rapid change, you have to repeat the entire security test. So, and that becomes a big challenge in the operationally. It becomes a huge. Either that investment has to be made, and if people cut short that investment, then you run risks of catastrophic failure.
So, do you see some clear mitigation techniques or technologies?
Well, so there are two broad sort of approaches. Definitely, we would expect that whoever puts together the solution, whether it is the telecom company or there is a independent IT company which actually puts it all together and offers the final solution. See, different scenarios can be there, but somebody has to make the investment in doing more thorough system level testing. Right? That I think is a must, right? And after the rollout of any major upgrade, that has to be done, just like you do in the application domain. So when you launch a new cloud version of a cloud application, you launch the new income tax portal and you see what all happened, right? So when you build a application which uses multiple pieces from multiple different parts, and then you have your customizations on top of that, a very thorough testing is needed, both from an application and functionality perspective, but from security, unless we legislate it or demand it, sometimes the vendors may, from a cost perspective, cut it down. So that's a big concern. Second is, as a user and as a system design, just like in the internet, we are used to the fact that whatever applications we use, there always will be vulnerabilities. So we have to be much more careful end to end in whatever way we are using it. Unfortunately, that is the consequence. That we should not be letting too much of our data end up in all the not so secure intermediaries.
Yeah. What I'm saying is that all this is getting deployed in critical infrastructure. That is one part.
That's the whole problem.
The problem there. So could it be thinking loud that some sort of best practices or protocols which are generated and industry wide made applicable, so that these issues are taken care of? I mean, at least there is some consistency across,
Definitely. I think definitely the relevant organizations, including TSDSI, should work at defining what are the best practices for how do you combine these pieces together. Having too much disaggregation or too much multi-vendor may not be such a desirable thing. Even if you're going to do multi-vendor, you don't have to have 10 vendors. You could do it with 2 or 3 vendors only. And each vendor is then responsible for making sure a big chunk of it is thoroughly tested and seen interoperability. So these are the guidelines that have to be developed in consultation with the operators and the major vendors. And we have to push it at TSDSI and NCSS, NSCS and others should, I think, work with the vendors to define best practices, right? So that even how testing has to be done, what all has to be tested, what security testing is minimum required before something gets rolled out, right? These are all aspects on which at least broad guidelines can be developed, and then we can learn from that and make it more specific also.
Many of these applications, there individually you could test them, but I think that context awareness and, in a particular environment, there's a function. You might have to create an environment also for that to be tested comprehensively.
Right.
So I think the test setup itself, design of the test setup itself could be an issue.
Definitely. That's, having a huge suitable size test bed where things get validated first is an important piece of the puzzle, and we should encourage in
Yes,
that
yes.
test bed for other parties to help us with the security testing also. Somebody like, just like we do bug bounties and things like that in the software space, right? We could partner with people who specialize in security and who are willing to.
Yeah. See, because many a time these simulation environments really do not create real life
No,
situations.
they will not. You're right.
They will not. So, and they're okay for certain applications, but for critical infrastructure, there's an issue there. So, I think how do you minimize? Yeah, how do you minimize that context-aware infrastructure, but still create a real-life environment? Is a problem statement that has to be addressed.
Yeah, and over time, assuming containerization and this business of slicing is working well, we could even define a network slice, which is an experimental network slice. And there you could demand that everything that is getting deployed would first be tested out in the experimental network slice, which is not where it is only people playing with it to, and then you, once your technology has matured there, only then you are comfortable rolling it out.
May I just quickly invite Sunil, if Sunil has a product cut to this?
Yeah, thank you very much. Very interesting point.
In a minute or two.
Yeah, it's a very interesting point. I'll just tell you, there are some best practices. Though basically what we do is at a system level, you do a threat modeling. The whole idea behind is that you understand the threat surface area, and then different threat vectors that you may have. And then you have to eliminate them one by one. For example, when we did a quantum cryptography box, while quantum technology itself is supposed to be providing a unconditional security, but it was a challenge for us that our box gets into telecom network or a data center. How do we model it? So we look at three aspects of it, right? We say, okay, our operating system could be vulnerable, right? Harden the operating system, reduce the surface area, attack surface area. Second one was that if somebody comes in from the internet and come into our system, how do we isolate the attack only to a limited area and it cannot access the other important area, because in our system we keep the encryption keys at times, right? So how do we protect that? So that was a third part, which is very important, side channel attacks, right? Now, for example, when I'm reconciling the key, somebody could actually capture a power consumption pattern and figure out where my zeros and ones are, right? So we looked at it and said, okay, how do we randomize the way we reconcile the key so that the hacker can never understood that in which order we are accessing the key, right? So these are some of the aspects, and of course, as Professor Sun said, a very important test bed, independent security vendor, and a theoretical analysis of security is very important.
Thank you.
Yeah, but one thing is, you talked about threat modeling. You as a vendor is doing the threat modeling.
Yes.
Yeah,
we are doing it for our own product, for our own testing. Then we independently give it to a third party to do it and validate it.
Yeah, so that is, there's a certain amount of maturity in your organization, and then they are doing it. So the problem statement here is, when we have multiple small vendors coming in, how do you enforce this activity of yours onto those?
Part of the RFP and part of the selection process, because it's so important.
Yeah,
right? Otherwise, you don't select the vendor, right? Not on the basis of functionality and the price. Of course, those are important. Yeah. But I think security has to have enough weightage in the RFP process and selection process.
Yeah.
So security for systems integration is one aspect that becomes really important. Test beds become really important. Threat monitoring, logging, and vulnerability discovery and disclosure becomes very important, because you are more or less building it as you go. So you are bound to trip on a few of these. The importance will be how quickly do you find out and how quickly do you respond.
Yeah, for example, in Cryptography box, if somebody hacks my box, I have a provision of zeroization where I can just delete all the data, so nobody get access to it, right? So these are some of the features, though. Of course, it's a feature, but it's a security feature.
I would have liked to go to Vishnu for AI comments, but Mr. Narinnath, I think we are at 1625.
Yeah,
ask if we can move along from this subject.
Yeah. Next one. Yeah.
Thank you. And the next subject is about how this whole concept of supply chain and IoT becomes secure with policy, standards, regulation that affect the identification of trusted sources, identification and labeling of devices, setting up control and reference points for inspection of security. So I'm going to turn to Gopinath to see if he has something to tell us a little bit about that.
Yeah, thank you, Sharad. It's an honor for me to be here in this session. It's great to see, there are so many viewpoints. I think in the opening session, Mr. Narendra has correctly pointed out that, one of the key aspects for any solutions deployment is that to have a proper design. In fact, one of the big challenges is that because of the cost, most of the solution providers would not consider security as a main part. Yeah, so let me just share and then just give an overview how IoT will actually play an important role and what are the key aspects that need to be understood so that we understand what are the roles of each of those components. Now, if you look the design principles of IoT solutions, right? I will actually divide it into 4 main sections, which are the devices as the first, followed by the communication or connectivity, and then the cloud, and then the application. Now, after the incident, right, that Mirai botnet attack, followed by Virex, and then followed by Reaper, we now know that IoT is not an exception, right? So like any other devices, it can also be compromised, and in that matter, it can be easily compromised. So first, we need to understand in any solutions that we are providing, what type of data that we are going to collect. Is it type of environmental data? Is it an audio or video or location or personal information? And then try to identify what are the security weaknesses or targets within particular scope. For example, as shown here, right, the type of data are directly linked to the user's policy management, the storage of those informations, and so on. Second is the sensors and also the devices themselves. As we know, right, so IoT has a very, very limited power, the low bandwidth, they have low resources, and so on. And you cannot have a very high security encryption for that matter. So then how do you build those devices so that it can actually support some level of security, which doesn't take a lot of battery consumption? And then the other aspect is that how do you update those firmware that's been deployed? See, one of the challenges when we deploy this massive number of IoTs, it is difficult for those solution providers to manage those devices. You're talking of billions, right? How do you manage those devices so that it can regularly update, send the patches properly, and so on? This is a big challenge. Next, we have the next level is the gateway. Gateway here, we talk about the different types of communication protocols, interoperability, and so on. So here the challenge would be how to have a proper policy management, not to, to also make sure that the hardware design can actually accommodate for the various independent types of devices that's going to be connected to the gateway. Next, I think the previous speakers panels has mentioned about the need of this various aspect of communication. So we have seen that a number of connectivity or communication has flourished over the years, specifically for IoT, whether the communication is secure or not. Next, we move to the next level with a public, private, or hybrid cloud deployment, and also platform per se. There are thousands of platforms out there, specifically either horizontal types of platforms or vertical types of platforms. So what are the policy, what are the code that need to be deployed in that particular area? And the most important is, of course, web and mobile applications, right? How this web will ensure that, the code is not compromised, proper penetration testing is conducted, and so on. So with this, right, so we can identify at each layer what are the best practices, what are the requirement, whether it is required by the supported by the manufacturer or the solution provider, and so on. I think one of the question, I think by Mr. Narendra earlier, right? So who's responsible, or Mr. Sharad mentioned, who's responsible? Is it the device manufacturer to ensure that devices is properly secure? Or is it the solution provider to ensure that the end-to-end security must be there, right? So it's a chicken egg and kind of a thing. Do manufacturer provide a proper encryption within the device or not, right? So this is the first part. So coming back to the policies, the code, we have seen that quite a number of organizations are already providing different kinds of, I would say, codes, right? So some of the, for example, NIST, which is the US agency, so they have actually come up with the Improvement Act, IoT Improvement Act. So similarly, we have seen that ENISA, which is a European agency, so they have come up with the IoT consumer devices baseline security.
Absolutely.
Right. So even then, right? So even then, how do you ensure that those manufacturers follow this guideline?
Excellent. May I?
Yeah, please.
So thank you very much for articulating so clearly the layers in this entire food chain for what has to be securitized. You asked some very important questions, and I think we still have Mr. Singh here, if I'm not wrong. May I just check that Mr. Singh is still on the panel? Because your questions about security assurance and compliance and your questions about who is responsible are things that the policy in India, the changes that were made, if Mr. Singh is still on the panel, the new gazette that came out in September 2017 in India made it squarely a responsibility of the manufacturer on one side and of the service provider on the other side, saying that only certified devices can be allowed to connect to a communication network. So a very important step was taken in India 4th September 2017 in making the responsibility squarely on both the manufacturer and the service provider. And that is what Mr. Sushil Kumar talked about when he said that the mandatory testing and certification of telecom equipment, MTCTE, is now following through. It's more or less like saying assuring the ecosystem of the fact that a device is certified. But then came the question about, okay, you sent a good device to the field. What happened during its life cycle? Is the software still secure? And I think that question you brought up. So maybe I can bring it back with this question, the second part, which is this entire data source validation, the constraints on the IoT devices with their capabilities in terms of security, in terms of processing, power constraints, etc. Where are we going with these protocols, specifications, and standards, such as to get closer to the point where vulnerabilities can be quickly detected, life cycle, over-the-air software management, those assurances can be better provided? Would you have some view on that?
Yes. Thank you, Sharad. I think we need...
I think Mr. PK Singh is not there.
I don't see him pick up the question, so maybe either he has got disconnected or...
I think he's still in the...
He is on mute, I guess.
He's on mute, okay.
Okay, yeah. Maybe Mr. Gopinath can...
Yeah, please. So on the part of data validations and so on, so it is, I would say, it's use case specific. When I say use case specific, you see, if you talk, for example, IoT in a healthcare sector, right? So the devices has to be, has a very high quality and must be securely, security features must be there embedded within the devices itself before the data is processed. So whatever parameters that the device captures need to be analyzed at some point, sometimes at the device level, and then send it across to the cloud platform. So if you take the same IT solutions in the agriculture sector, the devices would not require to be highly secure. So the security part, the processing of those devices, the validation of those data can be at the edge or could be at the next level. So how do you secure? So is there any methods to use all those things? I think there are some basic guideline. IETF has provided a lot of RFCs on security these constrained devices by using, specifically the CoAP, the MQTT type of connectivity and communication. So it is important first identify where the solution is going to be deployed, and then see what are the best practices that can be applied. Now, another thing is that, Mr. Sharad mentioned, India, it's good to know that, the common, the fundamental security must be there in the devices. One of the big question is that how to enforce, right, of all IoT devices to have a baseline security, at least, right? One of the suggestion was, in Malaysia, I'm not so sure if it's India, we have that, that in electrical equipment, right? For example, the aircon or the refrigerator, they have a star rating in terms of the energy consumption. The 5 would be the best in terms of the low energy consumption. So similarly, if we can come up with the standard security validation of all the IoT devices, say that a device only complies, say, for example, 5 out of the 10. So we rate them, say, 2.5. And one device, comply 10 out of the 10. So we rate 5 of those. So these are some of the suggestions that we in Malaysia, we are planning to deploy as well. So in terms of the, in terms of the data, right? So it is also important where you want to analyze the data. It can also be validated and analyzed at the application level by using some data analytics, machine learning, AI, and so on and so forth.
Is this what you meant, Mr. Gopinath, which is use case classification and compliance along lines of a certain grid?
Right. Yeah, something similar to this.
Okay, very good.
Right,
I will stop sharing. But maybe we should continue this discussion offline between TSDSI and MTSFB, because TEC took this view about 2 years back, that this kind of classification is important, and took about almost 50 use cases and studied them and qualified them. So instead of just running out of time, Mr. Narendranath, I think we will probably have to move on to the next question. I do see that on the question answers.
No, I think, Mr. PK Singh is there. If he would like to interject.
Oh, yes, of course. I see Mr. Singh is back now.
Yeah, Mr. Singh, can you quickly interject on that?
Yes, sir. Thank you. Underlying theme across the two questions which have been put to the panelists is that there is a need of doing security testing and certification of any product which goes into the telecom market. When I say telecom market, it is basically the telecom service providers network, or it is capable of getting connected to the telecom service providers network, that is by the users. So any product which goes into the telecom network or is capable of getting connected to it requires to be tested and certified against a certain standard. And when I say the security testing, having a grading of, let's say, a 5-star grading of similar to electrical equipments, I think that approach will not be applicable to security testing. In security testing, if even a single vulnerability is left untested, undetected, it may compromise the critical information infrastructure. So if a product has to qualify, it has to be a binary 0 or 1. It will qualify or it may not qualify. Even if a single requirement is not getting tested and complied, then the product is not fit to be connected into the telecom service providers network deployed by telecom TSPs or used by the users. So we need to have a product which are completely compliant to the security requirements which are to be drafted, taking into consideration the international standards. And
I think Mr. Singh, I think what he meant was that, if you have a classification of these devices, then, they would have different security classifications. Of course, each of that device will have to fully comply on a binary basis, as you said, so that the security requirements for that particular classification.
Yeah. I think on another part is that, I think India has actually adopted the baseline IT security for consumer devices. So it's a similar, that means it's a baseline. It's not that it fully comply to all the security. It's a baseline security. So similarly, we are also trying to adopt the same method of first getting all the consumer IoT devices to get certified and with the baseline security. So if they actually say, for example, go one level ahead of complying other types of security requirement, then it'll be good. So that means we can rate them higher than the baseline security that is already there in place that need to be complied. So that's what I meant earlier. Yeah, and I totally agree with Mr. Singh that security, you cannot say half comply, no comply. It must be 1 or 0. Yes, I totally agree with Mr. Singh.
So the idea primarily was to say that if it is a sensor that is reporting weather, for example, it is enough for it to have a username and password, and then all must be tested for proper username and password. But if it is a health device that is transmitting, let's just say, blood pressure data from an ambulance, then it has to have a different level of security, different level of encryption. And within those classification, all the specifications have to be met so that it is 0 or 1. But different classifications, different requirements. Okay, we should move on. I see one question on the Q&A, which is slightly related here. It is coming from Mr. Majid of IIT Delhi. Says, I saw a slide related to know your customer machine having UID Aadhaar linked with identity of the machine. Do this have any potential risk of privacy leakage or linking with user with such vulnerable state-of-the-art IoT device? I think a very quick comment, I can take that, which is to say that all of the key identities, when used in any derived manner or in any affiliate or associated manner, are best first transformed. So, for example, when IMSIs are used in the GSM network, they are transformed into TIMSIs, TMSIs, before they are sent over the network or across the network. So a very quick answer to that is that there should be transformation of the sensitive data, sensitive identity data, personal information prior to its being associated for use in use cases where they can be exposed. But this very good suggestion, Mr. Majid, and we will put it back to those who are sponsoring this work in the study group of TSDSI. Thank you very much. Mr. Narinath, so should I just move on now to the next question?
Yeah.
Bank,
yes.
There is, and here we come to a very important aspect. We'll spend 10 minutes on this, which is this entire new era of heavy-duty data generation, consumption, analysis belongs to artificial intelligence and machine learning, and that as an enabler for security is a very strong tool. So the question to the panelists is, how do we look at the current state of artificial intelligence and machine learning in terms of utilities that can detect abnormal behavior, that can detect vulnerabilities, and intelligently tell us unsuspecting human beings of what is going wrong? And I think we have an expert here in Mr. Vishnu Ram. I'm going to direct the question to him first. What is the status of utilities? What is the status of evolution in that technology area, which can bring some relief to quicker discovery of the threats and vulnerabilities? Thank you, Mr. Ram.
Thank you, Sharaji. Can I put together some slides, if that is possible, yes. Akash, to share those?
Yes, please.
While it is coming up, I have to say that I really enjoyed the discussion so far. In fact, it is my quote-unquote stories, as I call them, is very much related to what Professor Saran was saying, Sunil was saying, Gopinath was saying, and lastly what Mr. P.K. Singh was saying. So I think this is very well aligned. Thank you so much for the great discussions. I will just take a couple of minutes and tell you some stories. So this is the first story that I would like to talk to you about. It's actually a real life. Actually, all of these are real life stories. So it's about a network operator who wants to push for disaggregated open interfaces, etc., etc. They want to also enable SDK based app ecosystems, and they are worried about secure integration. We discussed this just now actually, and they are also worried about multiple split options. 3GPP talks about it, ITU talks about it, HC has different set of options, and we discussed about trust levels, cloud deployments, etc. So choosing these data consumers becomes a little tricky for them. This is what I understood from this particular use case. The story is to provide end-to-end trusted service for this operator. So one of the things which they have turned this AI ML as an enabler is basically to show that this solution alternative is to give an adaptive security app. So that means that your solution, security solution, becomes adaptive by using AI ML technologies. So basically what you do is you based on the desired privacy level. Here I go back to what Gopinath was saying earlier. You look at the use case. If your use case is specific about a particular privacy level, or if it's particular security level, then you choose your desired level. Then you choose your ML and data solutions accordingly, analyze patterns, but more important, prepare for the unknown. Here is where AI ML will really help you, because now I'll come to a little bit in the next couple of slides, a little bit. But here I won't go into details of this flow chart over the sequence chart on the right side. But basically the key takeaway is that it's not anymore survival of the fittest, it is the survival of the adaptive. So you need to use AI ML to adapt, observe the attack methods and adapt. That's what you need to do. Next slide, please. So this is story 2 actually. There is fault isolation and log analysis. Another network operator, they are trying to reduce the cycle time in responding to failures, coverage of security audits, checks, etc. They want to do that, increase that coverage. We heard about it just now actually. Analyze the logs and produce some audit reports, etc. has to be done as part of the compliance. Actually, we heard Mr. PK Singh talk about it just now in a different context. The proposed solution is to make it autonomous. So they are proposing that this is there should be an autonomous solution. Humans doing this is not anymore a futuristic solution for us. So AI based multi-agent systems, that's the proposal on the table. It may sound a little futuristic, but that's being worked upon. In fact, I am personally involved in a proof of concept which is actually doing this. And then I will take the main key takeaway here is that AI based multi-agent systems along with privacy preserving mechanisms. So I think Gopinath talked about smart edge, and Professor Saran talked about it, the slicing. Whichever way you look at it, the federated learning mechanisms, for example, and there are other privacy preserving mechanisms which helps us to increase the confidence in what we are doing in applying AI based solutions in multi-agent systems. Next slide, please. So yeah, this one is the real story 3. So here we are looking at adversarial sandbox. I think I want to hark back to what Professor Saran told about experimental network slice. This is exactly that. I mean, this is exactly the experimental network slice. Sandbox is nothing but that. So here the network operator is trying to reduce vulnerability in the AI/ML model, increase the confidence. We want to analyze the threat vectors. I heard Sunil talk about it, the threat vectors and surfaces. The proposed solution is that you isolate this in the sandbox for testing and validation, and those reports are to be used for identifying the models which can be deployed with confidence in the real network. There is an architecture which India is contributing. That's on the right side, along with our colleagues in TEC, we are working on this architecture. The key takeaway is that validation of AI/ML models in the sandbox, that's under works in the standards. Next slide, please. So this is an end-to-end picture. So this is how we look at it in a per use case basis. You heard Gopinath just now, but here we are splitting each of the nodes in the AI/ML pipeline. For example, you see the using a secure source APIs, trusted sources when you look at source. When you look at collection mechanisms, you look at location of data and aggregation in a secure manner. Then you look at models, you look at trusted, explainable, privacy friendly models. Then you look at distribution, you look at secure policies for adaptation mechanisms. Here, the key takeaway is you need to work on these standards. Currently, what we have is a high level architecture. And again, Professor Saran told this in the beginning that you need guidelines. So this I have underlined his notes. So these guidelines are very important for us as well. That's it. Thank you so much. And I can take any questions.
Thank you very much, Vishnu. I think you have, in the shortest possible time, delivered the highest possible clarity regarding the approach, the three approaches that you discussed. Again, in the interest of time, there is more discussions to be done here for federated learning and for future research areas. But we have a very important subject yet to be explored. So I'm going to request Mr. Narendra to move on to your fourth theme, which is what is quantum going to do to all the nice, beautiful architectures that we have built over the last 20 years. And I'm going to turn to Mr. Sunil Gupta of QNU Labs to ask him to tell us what is going to happen. We have put together root certification authorities, we have put together OCSP responders, and now we have the quantum threat. So please tell us a little bit about what are we going to see in the time to come, what is now, and what is the future?
Yeah, thank you very much. So quantum is now no more a research topic. It is coming to mainstream. It is a real threat.
Of course.
I don't know whether most of us probably don't realize this, that today quantum, we are already living in quantum world, because there are people on this planet who are moving with mobile phones with having a quantum chip inside, right? And several IoT devices are having quantum chips inside. So we are, India has, I think I would say, is also doing pretty good in this area. So as we know, the quantum technology is nothing but maybe if Akash can bring up my presentation, then
please, Akash.
So basically, quantum computing is about exponential speed up of computing, right? Using a quantum phenomena like superposition and entanglement. Given the paucity of time, I'm not going to get into those details. But besides, quantum computing has several good applications. Next slide, please. So yeah, so I just wanted to let people know that Google came up in 2019 with quantum supremacy, which means that they solved a problem on their 52-bit quantum computer in 200 seconds, which would have taken 10,000 years for Japan's strongest supercomputer to solve. China beat them after a year by 10 billion times faster than Google's Sycamore computer, right? And then in Samsung announced in 2021 a next generation phone which has a quantum chip inside. And Toshiba last week announced that they're going to convert quantum cryptography into a chip. So you understand that when the things move into mobile phone and you start miniaturizing into chip level, you can understand that where it evolved. So it is going to get into everybody's pocket, desktop, mobile phones, IoT devices everywhere, right? Nobody can stop it. So that's the way. So we are in quantum world, right? Next slide, please. So in terms of quantum computing, quantum technology is quantum sensing, quantum computing, quantum communication are three key arms. Quantum computing is the one everybody is going after, because this is going to define who is going to be the next superpower. In terms of the use cases of this is defining new supernovas, new materials, optimization problems, and so on, right? And drug discovery and so on. But one of the power of quantum computing, because of the exponential speed up of computing, is that it will break mathematical based encryption that we have today, which call it public cryptography, right? Which is based on a prime is based on a prime factorization, which will be possible to be done by the quantum computers in the near future. Thus, the only way for us to solve this problem is to rely on quantum-based communication to ensure cybersecurity. Right? Next slide, please. So I think that so basically what it means that when the quantum computers, sufficiently strong quantum computers there, basically it will break everything, because anything that is dependent on encryption today, whether it's online banking, e-commerce, cloud computing, emails, online, everything will be under threat. That's the biggest challenge. So we are looking forward to a data apocalypse, right? And now it's not about 10 years away, 5 years away, it is already here, right? So it is today's problem. And the way I define it, just imagine that when we look at movies like Terminators, where in the future, the machines take over humans. So only way for is to come back into the time, go back into the time, and change something so that in the future man will win and the machines will not win. This is exactly what the quantum we have to do. We have to take action today so that we change our infrastructure, change our cryptography, change our random numbers, so that in the future we don't lose war to the hackers. Go forward, please. So the two main issues in security, I'll just take another 2 minutes. Two main issues in the security: long-term digital identities. People steal our identities and they get into the system and then steal the data, right? So the digital certificates will get under threat. We have to make sure that they are quantum secure. Rather than classical certificates, we have to build quantum hybrid certificates. And then encryption has to change. We have to use quantum encryption so that once we encrypt the data, it is not secure only today, it is also secure in future as well. Go for it. So the three things that we recommend which to happen for India as well. First is basic thing, enhance. Enhance means remove all the pseudo random numbers, true random numbers in communication networks and replace that with quantum random numbers. Root of trust, absolutely perfect entropy. For example, 5G networks, authentication, when you do, all the users will come, they will register and authenticate, replace there with the pseudo random numbers to quantum random numbers, right? First, very immediate, needs to be done immediately, right? Second one is communication trust, where the data in transit, where the encryption is based, replace that with quantum key distribution or post-quantum cryptography, right? For example, all Wi-Fi and Li-Fi networks, which are security on them is done through VPN, can be converted into quantum VPN, right? In a very easy way, right? So that eavesdropping, man in the middle, harvest now, decrypt later attacks will be gone. Right, so we solve the problem of weak keys and weak tokens in our banking industry, healthcare, and then we by the quantum communication link, we stop eavesdropping and man in the middle on the fiber optics. And then third one is the store data, which biggest problem, ransomware. Of course, so one of the way to make ransomware ineffective is encrypt your data as storage with the quantum keys. So now what happens is ransomware guy will come and put another lock on top of it. But even if you don't pay him, he can't exfiltrate the data. It is useless for him because he can't break the quantum encryption. So we are taking a basically ransom out of the ransomware, right? So that's the whole approach of this crypto agility journey. That how do we take, and all this thing can happen without changing even a single wire, without changing any topology in the network. We can actually do it in a very seamless way, like plugging in a PS4 to a computer, right, or a TV. It is as simple as that. It's an upgrade. It is an include and enhance rather than rip and replace. Go ahead.
Okay. May I? Or
yeah.
You have some more slides.
Yeah, just one more. This is the 5G. You can put a QRNG and then you generate a pseudo, and instead of pseudo random number, you generate a high entropy standard number. Next one, I just want to show another IoT one, and then this is the IoT one. IoT devices. So we host. There's a possibility of quantum random number to be on the cloud. On the cloud, you can consume random numbers and you can provide as a one-time passwords, authentication, and so on. And also the chips are available now that can go into the IoT devices of new IoT devices that you're doing, so that they are secure in the future.
Mr. Gupta, if you stay on that slide, if you don't mind, please stay on that slide. General Sabarwal from the Indian Army has a question, so I might as well read that aloud to you.
No, I just answered his question, but anyway, you read it out, please.
I just read it aloud so that he has the answer. His question was, we are aware that future security paradigm would be increasingly based on quantum technology. Whilst it is possible to comprehend quantum being applied for conventional networks, how do you think it will unfold for IoT and networks based on IoT? So could you just say one more time what you said?
Yeah, so I'll just use the next slide to explain that.
All right, sure. Yeah, please.
Just move to the next slide, please. I'll just use that slide. So this is the way I see the critical infrastructure of future, and in India needs to be there, need of the hour. I'll explain, take 2 minutes to explain this. These are all IoT devices, edge devices, mobile phones. They're the quantum chips available there in India, where we can put this into these phones, IoT devices. Already we have done that. Is available to take IoT devices, because IoT devices require a very small form factor, 2 mm by 2 mm, 800 microamperes of low power, and you can actually build an encryption, right, embedded quantum level encryption into the device, right? So that is one level. Then second level of this is 5G networks. You go metro and area networks, you put quantum key distribution, right? All communication in this thing, you make it quantum secure. Now, between intra-cities, larger from Delhi to Bombay and so on, you can do post-quantum cryptography or satellite-based QKD. That is what we are also talking in India now. How can we develop India's own satellite QKD system, right? Connecting different networks together. And then you have entropy as a service, where random numbers are available on a cloud, where all the application can consume through an open API. It's a RESTful API or a Postman API. They can be used, and all this application, video conference, email, and so on, they can consume these random numbers and improve the robustness of the key, right? So your security and the key strength will go up, right? And today, for example, we are also talking, there's a provision to do, because Sharad talked about it. We are also talking about integrating QRNG with IDRBT certificate authority system platform, so that all the banks will start using a quantum level authentication, right? So this is the blueprint we have. I think this is what will provide a next generation quantum secure infrastructure for the country.
So some very quick questions, and I'm sure Mr. Narendranath has some up his sleeves as well. But thank you very much, Sunil, for this very engrossing disclosure of some facts and information. A quick question to you is, are private key-based encryption mechanism under threat as along with the public key infrastructure, or the quantum threat is only for PKI?
Yeah, quantum threat is available for public key, where the public key is available. So somebody can break public key and get a private key.
Yeah,
right?
I just wanted to make
that's the reason we recommend to move from asymmetric cryptography to symmetric.
Absolutely. And I wanted to make that point because one of the questions that we saw on the question panel is about this matter, which is to everyone, it's very important to say that if you are using a symmetric security, then you are at peace. It's when you use public key infrastructure that you have a challenge. And I'm not saying that's a small challenge, but where IoT is concerned, where telecoms is concerned, especially authentication that was based around USIM, all of that is based on private keys. Most of it is still following the same process. I know that the eSIM is moving on to using public key infrastructure, but most of the authentication that is happening between the card and the network is still private key, and hence in that sense secure.
I'll just add one point, just want to make sure that we are correct here. Yes, theoretically, yes, private key, symmetric key infrastructure will be safe, provided that keys are used as a random seed for generation of keys, and the keys are rotated frequently. Otherwise, people will find patterns in the encrypted data, and they will still break. They will find the right.
Just to add a small point there, that as rightly pointed out, you don't get exponential speedups when you're trying to search for private keys, but you do get quadratic speedups using Grover's algorithm. So what may have to happen is, if you are using 256-bit keys, you may have to double the key length to 512 bit to get the similar level of security when you're dealing with similarly when you're doing hashes for signatures, for example.
Yes.
Doing signature-based hashes, then that again is secure. Even with quantum this thing, except you may have to go from SHA-256 to SHA-512.
For example, you're right. AES people have moved from 128 to 256, right?
Right. So that much you have to do, but otherwise, the main thing that fails is the public key cryptography.
Yeah, and I just wanted to say that very quickly, because the question from General Sabharwal actually gets answered much more easily by saying that follow the symmetric key. for IoT, because trying to get from point A to point B may not be necessary. Okay, then there is another question on trusted execution environment, but I pick it up after Mr. Narendranath. Sir, do you have further questions for Mr. Gupta?
No. I think we should take the questions from the audience.
Thank you very much, sir. So, Mr. Kumar, Vireshwar Kumar from IIT Delhi asks that the trusted execution environment-based attestation or authentication is being considered as one of the potential solutions for ensuring the security of devices after deployment. Are we having some discussions about mandating its usage for IoT devices? And maybe I should say this very quickly, that the entire focus that NSCS has on end-to-end security and security by design, and the foundation of the National Trust Center is based around having roots of trust. And roots of trust are basically essential for building out what is called the trusted execution environment. So in a manner of saying, I'm not trying to springboard this, but the whole concept of end-to-end security, security by design, and the IoT National Trust Center is likely very much to respect what Mr. Vireshwar Kumar is mentioning, which is to have trusted execution environments, and then to have on top of that identity and authentication mechanisms that can identify the smallest of the IoT devices. Mr. Singh, would you have a comment on this?
Yes, so you are very right. The National Trust Center is what is going to provide authentication to a device, and the device can have any type of identity. It need not necessarily have just a IPv4 or IPv6 address as an identity. It could be any identity, and that identity authentication and authorization can always be facilitated through the deployment of the National Trust Center, which is currently being planned by TEC and is under consideration of National Security Council Secretariat also. Thank you.
Thank you, sir. My thinking is there is I think we had 3 questions on the audience, and those are answered. I also have come to the last question, which was in relation to quantum. My suggestion, sir, is that we are 7 minutes away from the conclusion of this session. So instead of trying to pick more questions, maybe in the interest of time, and we have a promise to run this seminar and this conference to time, may I just hand it back to you, sir, for your summary, and in between, if there are any points that any panelist or speaker might have, we can invite those. Over to you, Mr. Nath.
Yeah. Thank you very much. Are there any comments from the speakers? Anything else before we conclude?
Very minor addition, if you allow me. So as we were discussing quantum cryptography, sometimes, in security, we make the mistake. We say quantum computers are still 5-10 years from being generally deployed. So right now we are secure. But the challenge becomes that whenever we deploy some security application, it lives in the system in an enterprise or this thing for many, many years.
Yeah.
So what we are deploying today, for example, just to illustrate, in 2004, the normal hash function was found to be insecure.
Yeah.
Right? By 2006, actual attacks people had demonstrated. Large-scale attacks happened in 2008. And yet by 2000, even 8-10 years later, there are companies which were forced to move because they were under threat, because they had not moved their application. Right? So security technology, it's very important that we be proactive and push through the security technologies to be post-quantum now. Because once something is deployed, changing it is a very enormous task.
Yeah.
Right? So that is just my humble submission. I just wanted to add that. Sorry if I exceeded the time. But
Yeah. I mean, the way you concluded that once it's deployed, it's very difficult to change it. Is is the one that I also used to talk regarding IoT devices. And Mr. Sharad Arora would say that because we have lots of IoT devices getting deployed, And none of them is, we do not know if any of them is secure. And we don't have an option we don't give an option to any of the enterprises or consumers, retail customers, to procure secure Iot devices. So that's what we're talking in terms of having security requirements for Iot devices, classification, then security requirements, certification against that, and labeling, so that the citizens of any country and organizations of any country have an option to purchase a secure Iot device. So that is very close to our heart at the NSCS also, because we understand that once these are deployed, it becomes very politically incorrect to recall all those devices and say, no, these are insecure devices, replace them with secure devices. It would be humongously impossible to take a decision in that regard. So that is one that's what we want work to happen in that regard. And it's good, the MTCT, and once you have secure devices, the challenge there is, how do you enforce that people only purchase secure devices? Because the non-secure devices are cheaper, and people could go ahead with purchase non-secure devices, and they could be attack vectors. So the MTCT, that the mandatory testing for certification of telecommunication equipment, provides that framework, the rule-based framework, which makes it mandatory for people to deploy only secure devices. So we should implement the MTCT in Toto and bring in IoT devices under the framework, and come up with the security requirements along with other functional requirements for IoT devices. So that's an important part to take off from what Professor Saran had talked about. So we've had a very good session today, and some of the things that came about, and I would just like to pinpoint us, put pointers out there. One is regarding the participant, and Sushil Kumar was talked about that they were participating in standards making bodies. The NDCP 2018, has one chapter, and PK Singh also talked about policy framework. So at the national level, we have the NDCP of 2018, and there's a Secure India, and it talks about ensuring sovereignty, safety, and security of digital communication. Under that, we have one, build capacity for security testing and establish appropriate security standards is one, and then comprehensive data protection regime for digital communication, and participation in standards organization. So these are three, among other things, these are three things that as a policy framework that the government of India has come about. And I think we should, as all of us, strive to, implement these policy statements, these desirable policy statements. Then we also had, talk about the root of trust and the security classification, the trust model, and the identity and authentication, and what as Mr. Sharad Arora talked of Aadhaar for device and apps. And he was particular about using existing identity and authentication mechanisms without really complicating matters, going for something new. So the thing here is, we have been having lots of talk, and I think here what is required is to come up with an implementation roadmap. We have had enough of talk, and I think we should have targets now. And how to go about establishing this and getting the National Trust Center also in place. So that is, I think, that should be a targeted activity for us. We are in talks with TEC and DOT, and we are very actively interested in supporting the initiative of DOT in putting the National Trust Center in place and getting these things in place. Regarding the secure by design, where we had the panel on for disaggregated networks. So that, of course, is something that we are seeing a challenge that's going to come about. And I think the test beds is something that we talked about there, and security of for systems integration. Professor Saran had pointed out that we require test beds and security for systems integration. Here also, I think TSTSI could have a role in coming up with some guideline documents or some templates, so that organizations could apply it amongst themselves for the security by secure by design is applicable across all of these different entities which are producing pieces of a solution. And I think there's a place here now for integrators to come in and then play their role, a very big role that the integrators would come and play. Okay, of course, then we had a very important session on where Mr. Gopinath had pitched in, and and then Mr. Vishnu Ram also pitched in regarding the AI/ML. Actually, the amount of data that gets generated and the real-time nature of responding to security requirements, it is imperative that AI inevitable that we have to use AI and ML for behavioral analysis and then doing predictive analysis for securing systems. So there is a big role for that, and there's a lot of research happening. And from our organization also, we are sponsoring research in this particular area, especially regarding traffic. Gross traffic. You're taking traffic and then looking at traffic and metadata, and trying to come up with predictive analysis for security incidents. So, and Mr. Sunil Gupta had talked about enhance, strengthen, and fortify. He had used the terms very apt, and it's really proud of having an organization like CUNY Labs come up in our country. I mean, wherever we talk of quantum, CUNY Labs is one thing that really pops up in everybody's mind. But we require to have more. Yeah, but I think considering the size of our country, I think we should build a bigger base of organizations that work in this area. And finally, the talking of long-term digital identities and the future security of data, that's very important. Yes. And he had talked of solutions deployed now stays in life long, what Professor Saran had talked about. So it's important that, this realization that quantum is somewhere away and then, we can go and it's business as usual is not required to be done. And we should actually start, because we already have products in place. We have the QRNGs in place, we have QKD mechanisms in place, and post-quantum cryptography is also in place. So I think we should start now looking at current networks, like the telecom networks, for example. The DOT should seriously consider that, how do they secure their networks, and how do they migrate to, using random net generators and QKD systems put in place among, in a network-wide deployment, not experimental. I'm not talking of experimental deployments. They should be thinking in terms of projects for, commercial deployment across all the networks. And that whatever learning they get out of that, then we can start applying to other sectors. So with these are some comments that I had, and thank you again for all the panelists, especially Mr. Sharodharara for really piloting this right from the beginning to get to the shape that we have got it to today for the session, and to TSDSI for all that. Thank you very much.
Thank you. Thank you.
Thank you, everyone. I also just quickly say that these sessions work because of the tremendous amount of work that goes on in the TSDSI back offices. I want to thank Akash, Asif, Aditi, Vanshika, and a whole lot of other names that don't yet readily come to mind. But thank you, TSDSI, and thank you, Secretariat. Thank you, Bindu. Thank you very much to the speakers. A special thank you to Gopinath. It's getting to be around 9:45 his time. And a very special thanks to MTSFB. We hope to work very closely together in TSDSI and MTSFB. It's very important that we converse and collaborate on these emerging areas. And thank you very much for your participation here. Thanks to the very patient and nice audience that we've had from 100 odd people that have joined today. I think sessions like these spread the word, the importance of what is the status of these critical technology changes, and how we have to adapt becomes so much clearer. So thank you, everyone on the panel. Thank you, Mr. Singh, for staying back on the panel and adding so much wisdom and clarity to us. Thank you, Mr. Gupta. And thank you, Professor Saran. Very important that we had you and Mr. Vishnu Ram. Always a pleasure to have you as well.
Thank you.
Thank you, everyone. We are going to close this session now. And if there are questions that are remaining in the audience, write to outreach@tsdsi.in. We promise to respond to you very quickly. Write to us and we will take it up.
Thank you.
Thank you, Mr. Narendranath, for your leadership of this session. You have set the context. All the themes belong to you. I have done very little.
No. I think I'll tell you, major work is yours. Let's be very frank.
Leadership.
Thank you very much.
I hope we are going to follow through on the direction that you've shown to us. It's very important to execute now. It's very important to implement. And I hope we do that. Can I just check with the organizers? Can you put all the panelists and speakers on one frame so that we can take a screenshot? Is that possible?
Sir, we can be 4 on the spot.
Okay. All right. It's fine. Can you make all the screens equal? Is that possible? No?
Let me check that.
That just made my screen bigger.
I say these are customer requirements that people should consider.
Okay, all right. I think we are holding up the session. It's already 7:21, 6 minutes over from 7:15. Thank you, everyone, and look forward to seeing you again next year.
Bye.
Thank you. Thank you to all.
Thank you all.
Thank you all.